Hello, and welcome to Module 3. This week we're going to talk about pointers, which is a key aspect of C and C++. We're going to learn how to use them, why we use them, and we're going to also learn how to read and write to files. This is one of the most important parts of computer programming because data is usually saved somewhere where you need to read and write on it. So far we know how to output to screen or to console with cout and with puts. Also, you know that this is another one that you can input or you can output to screen. fprint is the other one. Fprint is another one that you can use for outputting, and you can take inputs from user using cin function, right? So now we're going to learn how to write and read from a file. Okay, so first thing is what we're going to go through is, first of all, we're going to clarify or talk about how to develop a code from algorithms. So this section is going to be added to Module 3 based on some inputs from Homework 2. And this is, you have freedom to design your code, but there are things called a best practice of coding, and it's important to have an idea of what those are, because ideally you can optimize your code so that it takes less time to run and you have less operations to go through. Also, we're going to talk about structured programming, which is a key aspect of algorithms. Then we're going to go through logical operators, which are useful for conditionals. Then we're going to talk about selection statements, which are also important conditions that you're going to end up using for your if and f conditionals. And we're going to talk about numerical techniques, which is a part of this particular class, how to use programming for numerical techniques or for solving problems in engineering. Then, as we said before, we're going to talk about pointers, which is a C and C++ functionality. And then we're going to finally write and read to files, which is important because most codes end up writing or reading files anyways, and B, because this is going to be used for project 1. So how to develop code from algorithms or for algorithms. So if you have the algorithm, how you use that algorithm to create your code, or how you take a problem. Also important to know how to take a problem and create the algorithm. So first of all, the algorithm is created by following or developing sequential steps. So you have to follow certain steps or the problem doesn't get solved. You have to break the problem in small parts so that you can create functions or portions of the code that can divide the problem and then execute it in parts. So for instance, if you need to open a door, probably you would like to have a sensor that tells you when somebody's coming up or approaching the door, or something that tells you that the door needs to be open. Or if the door needs to be open the whole time, then probably you remove the door or you put a book by the door to hold it open. So depending on the problem, you divide it in small steps and take a solution for it, find a solution for it. The breaking the problem part is pretty straightforward. In the problem where you have to find the velocity or trajectory of a bullet or a body, and then you have time versus velocity, for instance. then the first thing that you would like to know is, first of all, velocity is a function of time, right? So you can, and you know this because the units are meters per second. So really what you need to know is the distance and the time. But by knowing velocity and time, you can know the distance. So assuming that you know the velocity if they give you time, so the first thing you need to do is read the time from a chart or from the function that you developed. And then what you do is compute the velocity. If the velocity is equal to 3 meters divided time, right? So they will give you meters per second. So meters being distance. If the velocity is 3 distance divided by time, then each time you input, and then the distance could be a constant, or you also ask for the distance. This is a function that will tell you the velocity. Once you input the distance and the time, you can compute the velocity. Same for acceleration. If you know the velocity, you can create the recreate acceleration, because you know that the derivative of velocity is the acceleration. And then at the end, you probably want to print or save to a file the values, right? So this is a simple function or simple sequence to read and output values from a function. In this case, the function is velocity. Another example is, say you have to compute the area of a circle. So the area of a circle is given by the radius or the diameter. So area equals pi r squared. So the variable is radius or diameter, which are related. If they give you diameter, you can divide it by 2 and just get the radius, or you can ask for the radius and the user would have to divide the diameter by 2. So the basic operation of your algorithm is ask for an input, and the input is radius. You have to read it. So probably a cout, tell the user to input a radius, cin, get the radius allocated in r. So the flow of the algorithm is ask for radius and read it, compute the area. So you're gonna save pi as a variable. You say p equals 3.14, etc., etc., and multiply times r squared. And the algorithm is simply doing the operation, and you print the radius, the area. Okay. Area equals whatever the computation is. Now, this solves the problem, but what if the user inputs a negative radius? Well, because of the mathematical function, the negative radius will still work, because negative times negative is positive, so you will still get a positive area, but in reality, you can't ask for a negative radius, perhaps, unless you're being very strict in a CAD design where you have already 0, 0 at the middle, and you want to start your radius from a point. But in this particular example, we didn't specify that level of detail, so that level of detail is not assumed to be part of the problem, or shouldn't be, at least. So you can ask the programmer that if the radius is less than 0, please input a positive radius. And if the radius is greater than 0, then you can do your computation. So this is a simple flow chart to create an algorithm to compute area. Notice that the variable is radius, because it should work for any radius and not just one radius. This is the important thing about computer programming. If you only need one single radius, then you can do it by hand or use a calculator. But if you want this to work for any radius, then you can program it and ask for the radius. So let's go ahead and compute the area using the C++ code. First of all, we're going to open def++. And then we're going to come here and we're going to say, okay, so let's create a new file where We're going to use mathematical functions, square root. So CMath is probably a good option, and we're going to input and output information. So we're going to use input output stream. So call the header IO stream. And of course, this has to be under include. Since it's the header, we don't need a semicolon. And I'm going to show you that if you just want to do squared, you don't have to input a new library, because this is it's called a header library, and that takes time to load. So that's one thing that we can do to optimize our code. So we're going to use using namespace standard for the standard cout, and we're going to create our function, main function, and we're going to create our block. So the first thing is we're going to compute pi. So we can put pi equals 3.14, or we can create a constant, a function that is much more precise, and that is with acos. Now with acos, or cosine inverse, we do need the CMath. So include CMath, because if you only needed to do r squared, you could just do r times r, and that wouldn't need CMath. CMath would be if we called power to do this operation, but we do need CMath if we need the cosine, the trigonometric functions. So we're going to use CMath for that, and we're going to say that a constant called pi, which is a double, and the constant here, if I think we probably mentioned this before, means that if you try to assign pi a different value somewhere else, the compiler will give you an error. So this line tells the compiler that the user or the programmer can't change the value of pi. So this is useful for some variables like this one, because pi is a universal constant, so you should not be able to change it during your code. If you change it through your code, perhaps you'll get a pretty bad error, not compiling error, but mathematical or numerical error. So by assigning the constant value, the compiler will never change the value of pi, which will make you more accurate. The code will be more accurate. And then we're going to say, okay, we need a variable called radius, double r, and another called a. And we're going to initialize them, but not to 0. We're just going to declare them. So in other words, I'm not initializing r or a. I'm just going to declare them, which is all I need. And I'm going to say, okay, cout. I'm going to ask the user to input the radius in meters. Okay. End of line. Cin will give me the value inputted and take it to r. So now r is a value that the user will input, and it will be saved on a double called r. And we're going to say if, this is my conditional, r is less or equal, well, if it's 0, then the area is 0. So I guess it could work for 0, the area being 0. So let's just say if r is less than 0, do, then we need another set of brackets, and then we're going to output, let the user know that we're not happy with that number if it's less than 0, and we're going to say please enter a positive number, and I have to only have one set of quotation marks. There you go. So as long as it's blue, I know that it's taking it as a comment. And since we want the program to stop, we're going to say return 1. If not, else, which I don't have to write else because if this doesn't happen, then it's going to jump. We're going to say cout. Any other condition, say a equals and we're going to say pi, which is my constant variable. Not constant because it's 3, 4, 5, but constant because it's unaltered. Times r times r. So r squared times pi. Okay, and then this is in meters. Yes, and then we're going to say end of line. And of course, we should say return 0 to make sure that there are no completion errors and not errors executing the code. So when we try to save it, it's going to say save it on, let's create a new folder here that is called week 3 executables. Week 3. And then this is going to be area of circle. And we have an error because it's say using namespace. And then return 0. All those are completion errors. And then we're gonna say run. Enter, input the radius in meters. Okay, so let's say 4. Okay, so 4 times 4 is 16, times 3.14, 50.26. Excellent. All right, so let's try another one. 0 meters. By the way, this is 0 meters squared because we're doing area. So compile again because I changed something on my script and run it again. And let's do -4. Then please enter a positive number. And notice that it quit. It didn't continue running because it said return 1, which is a break. You can also put a break here instead of a return 1. So this is the example for computing in the area, and I'll upload it to the module 3 section. All right, let's continue. So what is structured programming? Structured programming is defined by a sequence, which is what we did, ask for radius, compute the area, and output the area. Selection, so you have to select what computations you're doing, you have to select what operations you're going to be doing and which operations are going to be redundant. And repetition, so either by a for loop to doing different radiuses or by executing it each time you need it. So this is the structured concept of programming. The sequence of steps, the selection of operations, and repeating the operations until you get the value you need. This is particularly important in numerical methods because sometimes you have to iterate your solution until your error is small enough. So this being the number of iterations, for example, and this being the error, this is error, then the number of iterations usually decays until it converges. And this is because repeat, or this is also called iterations. So for instance, in our example trying to compute velocity, we said that, okay, the velocity is a function of time because we already have the constants that tells us the distance. The distance is fixed. Say the distance between San Antonio and Austin, that's a fixed distance, but it takes different times for different people to get there. So we can compute the velocity. if you were to compute any velocity for any distance, so if you would necessarily didn't need to go to Austin, but you needed to go to Dallas or Houston, then in that case, the distance will be a different, it wouldn't be a constant, it will be a variable. But this example is saying that the distance is fixed, say distance between Earth and Moon at a particular angle. So we read the time, which is the variable that it takes to go there, and we compute velocity, then we can compute acceleration, and then we print the velocity and the acceleration. That is the whole program, so we can stop. And we already know that the function creates this curve for velocity and creates this curve for acceleration. So at first, when time is 0, there's already an initial velocity, which is 180. Okay, and then when 100 and time is 100 seconds, the velocity starts to plateau and starts to be steady, reaching maximum velocity, for instance. Well, in that case, when the velocity starts to increase, the acceleration starts to decrease. And this is counterintuitive, but this is only because, say that you are, for instance, in a case where your velocity increases, but you are not accelerating. It's just that, for instance, you're going in a circle. Remember that acceleration, if you remember your formula for force, is equal to mass times acceleration. So in other words, acceleration is equal to force divided by mass. So if your acceleration decays, or it goes down, could be that your force is going up. So for instance, if you're going around an orbit, okay, your direction is also changing, right? So in order to keep your direction changing, you have to input a force tangentially. So in that case, say that you're approaching your target and your force is decreasing. So if your force decreases, your acceleration decreases. Therefore, even though your velocity is increasing, notice that is 180, 190, until definitely makes it to 120 steady state. At this point, it's easy to see that when it's steady, then acceleration is 0, right? Because if you're not gaining or losing velocity, you're not accelerating. But it says that you are losing acceleration either because you are reducing your force, or because you're increasing your mass, or whichever could be. Also because acceleration has a sign, so remember that acceleration is positive if it goes up and negative if it's going down. So the other reason it could be negative is because the change in direction. So notice that this is nominal, is between 0 and 1. So the important thing here that I want you to notice is that we have a curve for acceleration, and then we have a curve for velocity. This being velocity and this being acceleration. Then we can go back and try to find out why the velocity increases and the acceleration decreases. Even though this is nominal, could be that its direction is negative, is going towards the negative direction, and that's why it's, well, in that case, it would be negative acceleration. No, in this case, it's positive direction, but it's decreasing acceleration. Okay, so in that, all that means is that even though it was having a initial velocity, is still increasing velocity, but is losing its is losing its velocity gradually. So At this particular case, I understand the curve at this point. So since it's 180 meters per second, so we're capturing the curve at the very last portion of it. So 180 meters per second is quite a lot. It's 108, 110 miles per hour. We're only capturing the moment where it starts to decrease the velocity or is not accelerating anymore. And even though the velocity still increases a little bit, it starts to reach steady state. And that's what is showing the acceleration curve. That is not accelerating steady anymore, is starting to decelerate, is starting to lose acceleration because it's probably reaching the target. So those are the curves. You can study them. And actually, we're going to generate the curves because this is the algorithm. We're going to read the time, and we're going to write or compute the velocity, and then we're going to compute the acceleration. So this is the code. Let's create a new code, and we can go ahead and replicate it. So let's create a new one, and it seems like we're going to use we don't need pi or any other trigonometric functions, so we won't use CMath. We will just use input-output stream. But first we have to include the header. Okay, then we're gonna use using namespace standard. Then we're going to create our main function. And then we're going to create a block of code. And let's go ahead and say return 0. And let's create our code. So at this point, we only need one velocity. So I'm sorry, before I move on, I wanted to show something here. Notice that in this particular case, I didn't initialize R and A. I just declared them. So if you were to do a cout of R and A, so let's do this. R equals R and A equals A. And you compile it again and you run it. Notice that, let's do an end line because it's a little convoluted. So end line and end line. Okay, compile it because I changed my code. Run it. Okay, so R is equal to 2.1 e to the negative 317. This is virtually 0. And A equals 4.9 e to negative 24, virtually 0. So this happens because R and A are being allocated in RAM in a position that has a 0 already there, or is not. It's an empty position in my RAM. It's not being used before because I don't have any software open or any other applications, or because my RAM is big enough and is big enough to allocate room for this kind of stuff. So since it's not being initialized, is going to assign the number that is already at certain position in RAM. It's going to declare R, it's going to declare A, but it's going to save whatever RAM position it was there beforehand. This is dangerous because if I end up having an error where I don't use R, I don't declare R, or I don't declare A, and I call them, I'm going to have a bug. So make sure that if you declare a variable, you end up using it. And if you're declaring too many variables, you should be able to at least initialize them to 0. This is good practice because then at least you'll know that you're going to get a 0 in your output if you don't use them, and then you'll be able to go back and say, oh, okay, I didn't use that variable. But sometimes you get an error, or you don't get an error, you get a value that is wrong and you don't know why. And a lot of times it's because the variable was declared but not initialized, and you use the variable anyways. Okay, so that was to say that in this case, I'm going to do the same thing, but I'm going to say double V and A, and I'm not going to initialize them because I'm going to use them later on. Double I'm going to create an array of times. And by now, you're probably familiar how to create an array. The type of variable is going to be a double, and the name of the array is going to be time. And this bracket, closing and open bracket, sorry, open and close bracket are to tell C++ that we're going to create an array. But the arrays are actually created with these curly brackets. The straight brackets are for declaring an array. The curly brackets are to actually initialize the array. And I'm going to create points for my time. You could ask the user to input a time, but for now I'm just going to create a different points so we can create the curve like we saw on the slide. And then I'm going to create a for loop. We know how to do for loops because we just had an assignment on it. So for loop has part to declare your conditions, which is I equals 0, semicolon. It's for I less than the size of my array. Well, since it's so small, I know that it's 5. 1, 2, 3, 4, 5. So I'm going to start from 0. It's going to be 0, 1, 2, 3, 4. So we're going to say less than 5 is 4. This is an int, so it's not going to be 4.9. It's not going to be 4.8. It's going to be 4 and then stop. And then we're going to say that it's going to go one by one, E++. Excellent. That's all I want. Now I'm going to input my function. V equals, and notice that V is not an array, so it's just going to do one at a time. If you want to create an array, then you can do the same thing and then save it at zeros, or initialize it with zeros, and then compute your array and save it in your array. And to save your array, you simply put V position I. But we'll talk about arrays later. For now, I'm just going to do one by one. So 1 e to the negative 5. Why e to the negative 5? Because if you remember, the expression is 10 to the negative 6. And then we have times. Okay. Then we have times the value of time. So time is an array. So I times squared cubic. Okay, so far we have 10 to the negative 6, then times negative 3 minus 0.00488, 0.00488 times time. So time position I. But we're not done. We have to do plus 0.75795, 0.75795 times time. And we have to do 181 plus 181.3566. Huh, okay. But I thought that this was times squared. And I don't see that times squared here. Oh, why am I missing places? And first, and also, this is 0.12345. Something's not okay here. So I don't like this at all, because this is the expression. I think it's a typo there. Times is cubic, then 4.488 squared. So this is squared plus 0.7595 times time plus 181. Okay. And then we have that velocity or acceleration is 3 minus 0.0062. Yes, so we have another one called A, which is acceleration, and acceleration is A equals 3 minus V multiplying 0.123462, and this is actually V squared. V times V times V. Right. Okay, so let's print velocity and acceleration. So we said that we're going to print after velocity, we're going to print cout, and then print velocity equals then the variable velocity and meters per second, and then align, and then A, computed A, then we're going to do the same thing, but instead of velocity, we're going to put acceleration, it's meters seconds squared, and this is going to be A, and this is going to be called acceleration. Okay, good. And then we're going to say that each value of the array is going to be computed with, we can actually copy the whole line and fix it. And then what we're going to do is copy this, paste it, and just say that each time we're going to just break the sequence with this pound sign. Okay, so what happens if we run it? Do we get any errors? Let's call this VA, val acceleration. Save. So IOStream, yes, it's not IOStream, it's IOStream. And then velocity is VY, I don't have here. And then meters per second and line, and line, and line, and line. Good. Now compiling errors. Let's see if we got any execution errors. Yeah, so 181, 194, 215. If we look at the curve, the steady state is around 215. Yeah. So my concern was that if we were to follow what the book said and put 10 to the negative 6, which is 1 order smaller. Oh, okay, well, that's why, because 10 e to the negative 6 is equal to 1 e to the negative 5. Excellent. So the only error the book had was that this is times squared. Good. We fixed it, and now we get the same values that the book does. So when time is 0, the velocity is 181. And we get that, yes, is 181. When time is, what is the time that we have an array? 80. When time is 80, we have 215, which is what we get here, 215. Now let's talk about the logical operators. This is very important because this is used for logical gates, for computer coding, for electromechanics. This is the foundation of logic. So the logical operator, the AND, is used for semantics, for when you talk to somebody, the or, which is exclusive. So and is inclusive, or is exclusive, and not, which is the negation. So the symbol is two ampersands. This means and, or is two vertical lines, which is or, and not is exclamation mark. So you can say if A and B equals 0, do that. If A or B equals 0, do this. If A is not equal to B, do the other. So this is how you use them. And the combinations are, so statement A and statement B, if A and B, if A is false and B is false, then A and B are false. It's not that because A is false and B is false, A and B are positive or true now. No, this is conditions. So you evaluate the conditions. So you did not eat breakfast and you did not sleep well. Therefore, and is the combination of eat breakfast and sleep well, false. So, or gives you, if any of them is false, the whole sequence is false. If one of them, if A is false, the negative of A is true, and the opposite of B is true because B is false, right? So if A is didn't sleep well, so if you didn't not sleep well, then you sleep well. Same here, if A is false and B is true, if A and B, then the whole thing is false. If and or B, then this is true. If A opposite of A is true and opposite of B is true. It's false, sorry, because B is true. If A is true and B is false, it's something similar. A and B becomes false. A or B becomes true. The opposite of true is false, and the opposite of false is true. And if A is true and B is true, then A and B are true. And A or B are true. Opposite of true is false. Opposite of true is false. So notice that if A and B combinations, all of them are false except for one, when true and true happen. If A and B are set in a condition, then most of them need to be true for that to be true. If A or B is the condition, then it's always true except for one of when both of them are false. And how to use it in a program is pretty simple. You know that conditionals, you have your if statement, which the compiler will understand as a conditional. You have your condition within the parentheses. And then if you have only one statement, you don't need brackets. But if you have several statements, you need to brackets. This is your statement block with more than one line. And you can create an else if you say if this else that. If you don't put an else, any other condition that is not the if condition will execute. If you need the code to only execute one or the other, then you would put your else. All right, so let's go through the conditionals and let's use them. So usually you would compare quantities for the if to be true or to be false. This is this foundational statement of logic. So you would use less than or equal, greater than or equal, and this is equal in an if statement, which is different. I want you to be careful here because it's different than if you assign a variable A equals 3. This single thing means the number 3 will be assigned to A. In programming, for the if loop, and this is in all programming languages that I know, if you say if A equals B, you have to write A equals B. So this is equal to. And this is not equal to. So the way conditionals work is looking from the algorithm or the block diagram. You have a starting condition, which is your code. And then let's say you have your variable x equals 3. If you have a condition that says if x greater than 0, and since x equals 3, this is true. And we'll go to this part. If x were less than 0, then this is not true. And then we'll go to this part. Okay? So we can look at this example. Let's go ahead and write a code. New code. And then let's write the code here. Okay, let's see. The first thing we're going to do is we're going to use the C standard class. So we're going to do include call C standard. And this is because we're going to use puts. This is another thing we're going to learn. Puts is like cout. Cout is a C++ extension. Puts is a C extension. So if most people are okay with combining C and C++, so for a simple code, you can only use puts, which is okay. Okay, so for instance, we're going to use int main. This is our function. Our block is going to be here. We're going to return a 0. And then what we're going to do next is we're going to say, okay, our first int is x equals 47 or 42, as the example says. And then our second int is going to be 7. So if x is equal to 42, then I guess I don't really need the open brackets because it's only one line of code. I'm going to say puts condition is true. X equals 42. And then, okay, so then we can say if, let's copy this if x is greater than y, then a condition is true. X is equal to 42 and y equals 7. Okay, we should be able to run this code x, y, and then we have if x is greater than y. Yes, the semicolon part. No errors. Yes, condition is true. 42, condition is true. 7. But if I were to put x equals 2, then nothing would happen because I don't have any error messages saying that else type. This is an error. So this is a very simple example of how to use conditionals. So another thing that we can say, if x is not equal to y, true, because one is 42 and the other one is 7, right? Okay. So you can have multiple conditions. You can have, if condition is true, yes, do statement 1. If not, this is what we had in our first example with the radius. If not, then simply jump that code. And then we have also, if condition is true, then do several statements. As we said before, for that, you have open brackets or curly brackets, I'm sorry. For this, you don't need the curly bracket. If not, then don't do any of those statements. So this is an example that you can go ahead and run, and instead of 42 and 7, you can put different values. This is going to be assignment homework. This is going to be extremely simple. As you see, you basically have to do what I just did, copy or rewrite this code, and simply put different values and tell me what the conditions are. For that, you can only focus on change this. But the trick here is that you're not going to write every time 42, 7, and the hint is that you will use cout and then plot or print the variable. Okay, so we want to do x equals the number that you input. I'll be writing down the assignment on module 3 so you can see clearly what I'm asking for. The hint is that instead of using puts, you're going to use cout or fprint.